Okay, so yes, thanks for the intro. And as mentioned, I'm Brad Axen. I'm the AI tech lead for Block, which you probably know better as the company behind Square and Cash App and Tidal. And I'm going to talk today. Oh, and another thing I wanted to mention is that I'm on the technical steering committee for the Agentic AI Foundation, which is the home now of MCP, Agents.md, and Goose, which is going to come up in this presentation a bit. So if you have any questions about that, I can talk about it later. And so yeah, today I wanted to talk about building with AI agent protocols and to have this be very concrete. So hopefully something that if you, like me, are spending all day trying to make agents work well for the people who are using them, you can hopefully find something useful here. And I'm going to breeze right through this because I think almost everyone has gotten really familiar with this. You use one of these every day. But when I talk about building an agent, I do not mean training LLMs. And so I really am treating that as like a third-party thing. We're going to use the best model to do whatever we need to do. It's everything around the LLM that we want to work on and optimize. So that's like the tool calling loop, context revision, and also the human interactions. Like how do you make it feel natural to work with an agent? So with that in mind, I'm going to start with kind of a part one, which I decided to just do completely protocol agnostic. Like what are patterns that are useful when building agents that I think no matter what you're doing are something you should know about? And then part two is going to be how do you actually go do that in some of the most important protocols that we have today. So the patterns. And I think there's two critical things that you need to do if you were building an agent. And one is to minimize your context window usage. And the other is to speed up the time to action taking. So the first one is about more like long range performance. Is the agent able to tackle complex problems? Does it like fall over after turn 12 of the conversation and then just stop working? And then the second one is, do you get feedback quickly as a person working with the agent? And probably all of us in the room are used to like waiting like 30 minutes to get your vibe code finished, and that's normal for us. But if you actually go put an agent in front of a consumer, if they don't see something happening in literally 2 seconds, most of them will just navigate away and do something else. So that matters a lot. And for me, I think probably the most interesting idea right now in agent development is progressive disclosure. So the first time I heard this term used in this way was in a blog post about skills from Anthropic, and that's probably what you all have seen a lot of this before. But it's been around, the idea has been around a lot longer, and it's really about loading the right context at the right time. And so let me show you an example of like maybe like the thing not to do and then a better way to do it. So if you're building maybe like an agent that does software development, soon you want it to be able to literally do everything that you do as an engineer. And you're quickly going to get to like 30 or 100 tools. And if you do this naively, you're going to give the agent all of those tool descriptions, arguments, instructions right at the start of the inference loop. And this just blows up your context window right out of the box. And so this is probably a lot of people who've had a bad experience with MCP, for example, this is why. It's because you were using an agent harness that did this, and it just like stopped working. There's actually a much better way to do this, and skills do this more naturally, and that is to give the agent only like a critical set of functionality when it's first opened. So in this case, like 6 tools. And then to give it one of those tools it activates other tools in turn. So in this example, like, okay, what if you have a tool called activate extension? It can turn on GitHub. And if you design your agent in a way that it knows what to do when it sees this tool, you can just add tools to your system. And then now suddenly, all the agent had to decide was that it needed GitHub, and now we have those 6 tools. So that dramatically minimizes your context window usage. And so this is, I think, really, a lot of people think about this for tools or skills, but it's not just tools. There's all kinds of context window content that you can progressively disclose. So instructions, that's the classic skill thing, right? Like read this markdown file to learn how to use our deploy system. But also things like resources, like grab a database schema or an API spec only when you need it. And even guardrails, I think this is a really useful one. If you fill your system prompt full of guardrails to make the agent not do bad things, uses a lot of context and actually makes it behave really weirdly, it's much more useful to turn them on only when you can detect that the agent is about to use a tool that needs some safety. So pretty much everything in the context window is a good candidate for this. Okay, but one critical trade-off back to the like time to first action every disclosure step is a full LLM inference round trip, which means like even with a fast model, we're talking several seconds. With a slow model, tens of seconds. And so you have to make a trade-off there. Having more tools up front means the agent takes action faster, but you use more context. Fewer tools, you get a leaner context window, but one extra tool call to start. And I think for most agents, the trade-off is having one level of disclosure. Like every tool is one extra inference away, and you can handle 1,000 tools like that, no problem. But then you don't blow up the context window up front. Okay, so then my second pattern, this is the one, if you're like building command line tools for agents or MCP servers, this is, I think, the most important thing to know about. Before we were talking about bringing context in at the right time, this is literally just being efficient. Like, how do you not put too much context into the window for stuff you don't need? And this matters a lot, right? So everyone using agents has seen this. If you get to even halfway through the context window, it starts to drop off performance. But obviously, there's a hard limit at some point where you maybe need to compact or do other compromises. So you'd rather just get the work done before it fills up. And for me, in every agent I've used or built, tool output is by far the largest contributor to the context window growth. And you can dramatically impact the performance of that with like pretty simple code changes. So let me say that the thing that almost everyone does, because it's so easy in every programming language, is to like take a structured object in JSON, dump it, and have that be the tool output. And unfortunately, that's almost literally the worst possible format. And so the reason why, just to like look at this, like that's a token, that's a token, that's a token. If you have multiple rows, you're repeating the same field names for every row in the output, which is inefficient, especially if you have a lot of objects to return. And so this works out to about 78 tokens for 2 rows of data. And like, turns out a CSV is almost token optimal. It's using the minimal separators. It has no repeated column descriptions. So this is like literally 3 times less tokens, 23 tokens. And there's a lot of other similar optimizations you can do, but if you just rechange your data structure so that the output is smaller, you can make the agent able to do many, many more actions. Another example of this that I think is underused is field selection. And it's another natural thing to do, right? So if you're having an agent operate an existing API, you might just grab the output of that REST endpoint and dump it out to the agent. And even if you optimize the format, it's still a bunch of unnecessary content. And the agent probably only needs like 1 or 2 things from this like large data model. And so giving it something like a SQL language or GraphQL, there's a lot of good options here to select exactly what the model needs to see can be another huge improvement. So in this case, like if you have a bunch of fields for your employees database, it's 260 tokens for 3 rows of data. But if you let it do a SQL query, it doesn't take any longer to get that data, more or less. It's about the same number of tokens in, but you get literally 1/10 of the tokens out. And so this is a huge deal. And the more structured your data is, the more it matters to have something like this that lets you filter it down. Okay, so one more pattern that I think is pretty critical is how do you bring the human into the loop of action taking? And I think the guideline I have for this is that you want the human to take any meaningful actions like writes or anything destructive or anything that moves money. It's not really approving tool calls. I think that's the pattern that we're all used to and we rapidly learn to ignore. It's more about showing them things that they can do proactively. And so let me try to give you a side-by-side, and I'll actually demo this in a second because it's a little bit hard to understand in the abstract. But most of you have used an agent that has a tool approval harness in the harness. So some generic setting you turn on where you approve everything. This has a bunch of problems. One is that you approve the tool before it executes. So the agent might have literally made a mistake. I'm sure you've all have done this, where you're like approving a bash tool that then fails, and it has to do it again, and you reapprove. So that's pretty frustrating. Another problem with this is that it's kind of opaque what the tool is going to do. Like at best, you're reading something that is a well-formatted function with arguments, but at worst, it can be just totally unintelligible. So I think a much better approach to this is to make rich UI for your tool outputs and execute them immediately. So you immediately, like say someone wants to make an order in this case, you immediately return a renderable object from the tool The agent can keep working. The human sees something almost instantly. And it's that renderable object has a button or some other experience which actually takes the action. And I'll show a demo of this because it's a little bit more clear. But just to say, why is this better? This is better for the human. It's a better experience. It's easier to understand. It's also better for the agent because the agent can, it immediately gets results back, so it can keep moving. It can validate and recover from failures. And if it succeeds, maybe it can move on, right? So it can keep running the loop. Another thing I really like about this is that individual tool calls can decide if they need approval based not just on the tool, but even like the arguments. So you can decide like, oh, this is a destructive thing I want to escalate to the human. Okay, so let me actually show you how this works in Goose. So we're gonna use Goose with like a live, this is like real MCP server from Square, and it's called Neighborhoods. And I hope my Wi-Fi is gonna be okay for this. So I'm gonna show you a couple of the different things that are happening. This is slower than it should be, so I hope I reconnect. There we go. So I have 2 extensions on to start. I have my developer tools that are on all the time and an extension manager. So this extension doesn't exist at first. So the first thing that Goose does is it decides, let's turn on the neighborhood extension, and that is what loads the tools into the context, like I mentioned. And this is working with MCP. So you can do that with anything. And then it's gonna start tool calling. So it's gonna find this matcha place, and now I get a rich UI rendered like in the window, and I can go navigate and be like, okay, I want a latte. It's telling me what I like to order, and I'm gonna say, let's get an uji matcha with the default options. So this is like, it's not actually that fun to type that in, but this works great if you're on voice, for example.
Is that actually using the MCP Apps standard?
It is. Yeah, exactly. So this is MCP Apps, and I'll show a little bit more about that in a second. Yeah. Okay, so this is really what I mean by the human in the loop part of the flow. So the agent immediately rendered this object, and I can interact with it, but this agent could have kept working if it had more to do. It validated that the item was correct before filling in the cart, like all that kind of stuff. And so it's just sitting here waiting for me to act on it, and I can hit the button, and then I go to a checkout flow. And this is actually like real. This is in my browser. If I hit place order, this restaurant will actually get me a latte. So this is live if you ever want to play with it. So that's the idea. And I think that's a much better experience for the person in so many ways. Like it has less failure modes. It is more intuitive what you're doing. And I think that really improves agents as long as you have an interface where you can do something rich like that. Okay. So let me tell you a little bit about how what we just saw worked and how you, I think, as a builder can take these ideas and actually use them in the protocols. But my first thing to point out is like when do you actually need a protocol at all? If you're building the whole stack end to end, like you control the interface, you control the agent, and you control the tools, you don't need a protocol at all, right? You just write functions and for loops. It's pretty easy to build an agent these days. There's a lot of great SDKs for that. So those patterns still matter, but the protocol doesn't. The thing that brings the protocols in is when you need to like have an ecosystem that you're working with. So either you want your agent to be able to use tools you didn't build, or you're building tools and you want to let other people's agents use them. Okay, so the first one, skills. So you've all probably seen a skill. It's literally the most easy to distribute thing in the world. It's a markdown file. This works in pretty much every agent harness. And this is like the progressive disclosure 101 idea, basically. It's literally just telling the model that there's a file that it can use its tools to go read and get more info about what you want it to do. So the model only knows a really terse, like it knows these skills are available, and it on demand looks up the content. I also think another really underrated thing about using command line tools is that if the tool itself has bad output management, the shelf can fix that, right? Because the agent can pipe it into JQ or grep. It can write it to a temp file and use like more sophisticated parsing. So that's really valuable. But it's harder to do human in the loop well because you're in a terminal, right? And it's not as obvious. Like if the agent is like running a bash command that calls a tool that then pipes it to grep, like what do you do with that? So that's not great. The other thing that obviously is the immediate deal breaker, if you're building like a web agent you just you don't have a terminal. So there's no way to use skills if you're building an online agent. Okay, so that brings in MCP. So this is much more globally compatible. You can use MCP anywhere and to build really cool stuff. And so this is an example of an MCP server using fast MCP. And this function is where you do all of the work for the patterns that I was talking about before. So like an example here is we're going to make a CSV formatted output. I'm not going to just do a JSON dump. And what I think is underrated is that as an author of these tools, there's so much context engineering that goes into this that you would not think about, like the output format. Every time you raise an error, the harness probably catches the error and it shows it to the LLM, which is good, but it means your error messages even are context engineered. Even the docstring here is like in the context window, right? And you want to make sure that's short and to the point. So there's a lot you do as an MCP developer to make these work really well. And I think that's the main thing to think about roles here, is that the person writing the MCP server is responsible for output optimization. So they have to do most of the work to get that right. It's hard for the harness to fix it if you did a bad job in the first place. But in reverse, progressive disclosure is all about the harness. So whatever harness you're working with, and by harness I mean things like Goose or Claude Code or AMP, you have to, the harness is the one that can control that. Sorry, I'm almost out of time, so let me rush a little. Okay, so then last, MCP Apps. So this is an extension to the MCP spec that you just saw in that demo where the client has like HTML to render. These are great. I use fast MCP a lot to implement these. So this is an example where you're returning like a low-level HTML, which we use a lot when we already have like existing UI frameworks that we want to build on top of. So that example uses this kind of MCP app server. And you control that kind of human-in-the-loop interaction basically in the HTML that you're showing to people. And then just to call out, you should definitely try prefab. If you were in Jeremiah's talk a little bit ago, he showed this off. I think it's really cool, super easy to build with. Okay, so for MCP apps, what are the patterns that we're talking about that matter here? One is that this is actually a really good way to do output optimization. So you can, in your HTML, the agent doesn't see that. The human does. So if you want to put a bunch of extra useful information into your UI, you can show the human that without filling up the context window. So that's super useful. The other one is this is where the first place I think really where you can do that human in the loop example that I gave. You need something that gives you expressive enough support that you're going to be able to like build like a functional button and like a UI that really previews the action that you're going to take. Okay. So with that, I'll start wrapping it up and just a recap of the patterns that we're talking about. Progressive disclosure. This is about loading the right tools and context at the right time, not everything all at once, and this makes your agent efficient out of the box and doesn't fall over early. Output optimization is more on the person building the tools, but it makes sure that you can take many actions and not just have a loop of 10. We're starting to push into loops of hundreds that the agents can operate. And then human-in-the-loop flows, I think is really critical to have these rich renderables that show people the actions they're going to take rather than just relying on them to either skip permissions or approve everything. And all of these things you can build with skills, MCP, and MCP apps. Okay? And that is it. So thank you. If you want to try out Goose, which was the agent in the demo and project we work on, it's at github.com/blog/goose. And maybe have time for a question?
All right, what questions do we have for Brad?
So in terms of the work that you're doing in the standards committee that oversees MCP, what are the kinds of things that you're working on in terms of agent-to-agent communication? Because this is like a great overview of kind of the first layer, which is getting your tools exposed to other people. Where would we look? Like, I know there's A to A, there's other sort of standards out there, but I don't feel like anything's really hit any kind of critical mass, even 10% to the point of MCP is. So I'm struggling a little to figure out, like, what's the roadmap there to look to?
I think is a great question, and I will say A to A is part of the Linux Foundation, which is so we're siblings there for sure. So we will I'm certain talk more about that. But I'll say that I think that with the Agentic AI Foundation, we're looking for the protocols and software that has hit like a certain level on the maturity curve where we're not like kind of pitching an idea. Instead, we're endorsing and evolving something that already has success in the community. And so I think the reason why we don't have one yet is because it's actually really early to do agent to agent. And so if we were out there with like a dozen agents that are all interesting that implement A to A, I think that's when we would really start to see the patterns emerge. But I think it's obviously coming, right? And so like, what is the actual protocol that we use? And for me, for example, I have like 12 agents that talk to each other in Slack.
Yeah.
And so it would be great to have something more formalized. So I'm sure we'll be talking to A2A about it.
At least you validated the fact that I'm using Slack, and
Yeah.
it's not as dumb as I thought it was.
Yeah, no, Slack is great.
Other questions for Brad? Chris? Sorry, thanks for your help.
Yeah, I have a question. You made a good point about field selection, right? But in deployment examples, right, like non-technical users are asking for things that you don't expect. So what are good ways to approach limiting field selection when you really are trying to let these things loose in unknown areas?
Yeah, definitely. That's a great question. And I think if you have an arbitrarily large table, I wouldn't let it have access to the whole thing. I would think through a lot about what you want the agent to be able to do on behalf of the user you're working with, and then give it kind of the intersection of like what's available and what is useful. And that that's hugely valuable to make it more likely to do the right thing, because you remove redundant fields, all the stuff that could confuse it. But ultimately, that doesn't end up being the whole story, and I often find you have to give like few shot examples to make it really do what you want to do. As every time the models get better, though, that gets less important. And I think in the very near future, all you're going to need to do is tell it like this is the deduplicated schema that you need to know about, and it will probably figure out pretty well from human intent.
There's another question over here. Maybe. Yeah, please.
Yeah, you showed an example of MCP apps, and it was a very basic example that MCP server returns HTML, and it's rendered in a chat. But my question is is there any more capabilities in MCP apps, or that's it? That it just can render HTML in the chat?
That's a good summary, honestly. It's putting HTML into the chat, but there are some pretty rich interactions. So in this example that I'm dealing with right now, there's some screens, for example, where if you click inside the HTML window, it can append messages into the chat. So there's actually bidirectional communication between the HTML, that the agent can update it and iterate with it, and the HTML interacting with it can send instructions to the agent. So it is a two-way conversation, and I think that builds some really cool features. Like another. Everyone has used an agent that has a to-do list, and I don't love them because they're always kind of patched on to text and everywhere. So I think this would be a much better version of a to-do list, for example, where it's just kind of sitting on the side, constantly updating as the agent works, and then you can operate it for it as well. So those kinds of things I think are really cool.
Talking about the MCP apps as well, I'm curious about HTML as kind of the choice there. We're seeing so much movement and momentum to the command line and kind of TUIs and text UIs. Is there energy towards non-HTML representations of UI?
Yeah, I completely agree. And I think HTML is a really high leverage first implementation, right? And that's where I think the spec is at, is that we wanted to get something into MCP that would let people explore the space. And then maybe someday soon we'll have a whole new language that is cross-renderable into multiple systems. That's hard. For what it's worth, I will say that this pattern, if you control the tool and the agent together, you can just skip the spec and return rich renderable objects and then just intercept them in the CLI, and you can do really cool things in TUIs like that. So I wouldn't stop doing that if you control the whole thing, but there's obviously not yet a standard where someone can build an app in MCP that Claude Code renders nicely. Yeah, it'll be, I think the hard part there is mostly just what's the language that's compatible. Yeah.
Let's thank Bradley again. Cheers.